Independent and dependent events, I want you to underline right now this first part right here. Events are independent if the occurrence of one event does not affect the probability of the other. So you have to make that decision today first. Are they independent events or dependent events? Is the occurrence of one going to affect the other, or is one independent of the other, even though they are together in this situation? So here's a mathematical way you will see it written. If A and B are independent events, so it's like event A, event B, they're independent of each other, then we would say the probability of A and B happening, the probability of A and B happening is written, we would take the probability of the first event, A, times the probability of the second event. So we just do a multiplication problem. Jesse, you want to? Probability of A times the probability of B. And we are going to do it in their fraction form when we do it, okay? So it says, in other words, if two or more events, even if there was 3 independent events, 4 independent events, it doesn't matter, we're going to multiply their individual probabilities. That's what's actually going to happen. We will just multiply what's the probability of each of them happening. So here's an example of an independent event. Well, maybe. An experiment consists of rolling a number cube twice. So you have this number cube, you roll it out, you land on a number, but then you pick it up and you roll it again. Is the probability of what you're going to get on the second roll dependent upon what happened on the first one? So if I have that dice here and I roll it out and I get a 6 the first time, and when I roll it the second time, can I not get a 6? No. I can get a 6.
You can.
The 6 doesn't wipe off of the number cube, does it? It's not there anymore. It's like it hasn't disappeared. It's still there. So rolling a number cube twice, that's independent of it. It doesn't matter what happened on the first one. That number's still going to be on that number cube the second time when I roll it that second time. So what is the probability of rolling a 3 the first time and a 2 the second time? So determine if the 2 events, this is always what you're going to need to do, though. You're always going to have to ask yourself, are the 2 events independent? And I kind of just said to you, they are, aren't they? Because whatever you roll out the first time, it doesn't go away. It's not like, okay, well now you can't get that the second time. So the first roll of the number cube will not affect the second roll. Therefore, the 2 rolls are independent events. So step 2, we actually now find the probability. So the probability of both of those things happening, remember, we want to get a 3 and then we want to get a 2. Here's how, if we saw that notation, that's what they would be saying. What's the probability of getting a 3 and a 2? So, and then we're going to multiply them times each other. So what do you think? What's the probability of getting a 3 on a number cube? How many 3's are there on a number cube? 1. How many numbers are there altogether? 6. So what's the probability of getting a 3? 1/6. Times, what's the probability of getting a 2 on a number cube?
1/6.
1/6. There's only 1 2 out of 6 numbers. So the probability that we will get a 3 followed by a 2 on the second roll, a 3 on the first roll followed by a 2 on the second roll is whatever 1/6 times 1/6 is. What is that? 1/36. And today, I think we'll still take those and we'll change it to percent so we stay in the practice of that. Let's divide that out, find out what it is as a percent. 1 divided by 36, what happens on your calculators? If you don't have one, get one out of my drawer. Let's go.
Let me grab it.
Yeah, thanks, man.
I'm a girl, not a man.
Thanks.
2.7 negative.
2.7 then. We're 2 sevens.
So
27 and 29.
Oh, wait, well, be careful now. How does it come out, first of all, on your calculator? 0. What?
That is very.
0,
Yeah.
2, and the
Two.
7
Oh,
keeps
yeah.
repeating, right? It ends in an 8 eventually, but why does it end in an 8
So it
again?
rounds up.
Because it rounds up. That ended in a 7, the next number would have been 7, so it rounded up to an 8. So we have 0.027 repeating, so that's really 2.7 repeating percent, but we know that that is, because we're so smart now,
2
we
and
know
7/9.
that is 2 7/9%. Okay. So, the probability of actually rolling a 3 the first time and then a 2 the second time is 1 out of 36, or a 2 7/9% chance of that happening. Okay, now let's look at this other one, this is another typical independent event one. You did this experiment, consists of randomly selecting a marble from a bag, so you have this bag of marbles. You select one out, and then it says, and then you put it back in again, you replace it. So you put it back in the bag again, and then you select another marble. So it says the bag contains 2 red, 1 white, 7 yellow. What's the probability of selecting a white marble and then a yellow marble? So remember the first question you have to ask yourself every time today is it independent or not? Or is this a dependent event? What do you think? Do you think this is an independent event? Does the chance of, we want to draw a white marble the first time, and then we want to draw a yellow marble the second time. Is drawing a yellow marble the second time dependent upon the white marble the first time?
Wait, say that again.
Kind of.
Is drawing a yellow marble the second, in your second draw, dependent upon drawing a white marble the first time?
No, because you put it back.
No, because you put it back. So how many marbles are in this bag altogether? 10. So if you draw out a marble, wanting to get a white marble the first time,
You have 1 in a 10.
then if there's a one white marble in there, you have a 1 out of 10 chance of getting that white marble, right? And then you put that marble back in, and so now all 10 marbles are back there again.
You have the same chance of drawing a yellow
So
one.
you
both
have
times.
the same chance of drawing a yellow one as if it wasn't, as if we'd never done the white one, right? The yellow one is independent of if we had ever even done the white one. So we find the probability of each of them happening because it is independent. So the probability of white we just said was 1/10. What's the probability of drawing a yellow out? We put that marble back.
7 and 10.
Are there 7 yellows?
No.
I didn't look up there. I'm already, it's hidden from me already. So.
Yeah, it is.
Okay, 7/10. Okay. 1 times 7?
7.
7. 10 times 10?
100.
100. Don't you dare divide this out on your calculator to get the percent. Don't you dare.
0.7.
That's 0.07, and anything over 100, whatever's upstairs is the percent. This percent is out of 100. So what percent is this?
7%.
700. It is 700. Yes, 7%. I mean, it is 700 as a decimal, and it is 7% as a percent. Okay. So again, sometimes we should not go directly to that calculator. Okay, let's go take a look at the first one that we're going to practice down here. 6 cards are numbered from 1 to 6 and placed in a box. 1 card is selected at random and replaced. So you can pick one out, see what it is, record it, put it back in. Another card is selected at random. What is the probability of selecting a 1 and then a 6? Okay, first of all, is this independent?
Yes.
Yeah.
Because you put it back in. That's the key word right there. When you put it back, so it's back there again, that tells you those events are independent of each other. So let's figure out the probability of drawing a 1. What's the probability of drawing a 1?
1/6.
1/6. There's 1 out of 6 cards. What's the probability of drawing a 6?
1/6.
1/6. So how do we figure out the probability of drawing a 1, then a 6? We multiply them together. So we say 1/6 times 1/6, which is
136.
136, which we have right up there. We really don't need to do it again. We can just continue on and say that is 0.027. There's 7 repeats. And that is 2 7/9%. So here's all of its forms: fraction form, decimal form, percent form. Just 3 different ways to state that same probability, okay? So if this was a multiple choice answer and they gave it to you as the decimal form, you would know how to get that form. Or if they gave it to you as a fraction, which is typically the way we usually get it right away. Okay, so we have number 2. If a coin is tossed 3 times, what is the probability of the coin landing heads all 3 times? Is this independent? No. Why not?
Because you 3 of them lines and 3 left.
Well, it says a coin is tossed 3 times. So I have this quarter, I toss it up, I let it hit the ground, and I want it to turn heads. And I pick it up and I do it again.
You have the same chance every time.
Because why?
There's 2 options.
Yeah, the heads didn't go away, right? After maybe it turned up heads, did I wipe that off and say, okay, you're now gone? No, you can't wipe the heads off of a coin. And so in reality, that's still there. Okay, you don't have to even replace it, it stays there. Okay, so we have the probability of heads all 3 times. Here's how we would write that probability: H, H, H. That's what we want to happen. We want to get heads all 3 times. Well, what's the probability of getting heads?
3 others.
1/2. 1/2. There's 1 heads on a coin, 2 sides to the coin. The other side is tails, right?
So will we have to multiply 3 of them?
Yeah. So we got 1/2. We got a chance of getting a heads the first time. Our probability is 1/2. Second time, 1/2. The third time, 1/2. It doesn't change. The heads is still there. 1/2 times 1/2 times 1/2. What is that? 1/8. There's our fraction probability, which is what as a decimal? 0.125, which is what as a percent? There's our decimal answer, and 12.5%. So if your parents say to you, I will give you $100 if you toss a coin 3 times to get it heads up, all 3 times. You say, The probability of that is not real high. Is it likely? Unlikely? What is it? Certain? As certain as not? Impossible?
That's not.
As certain as not? That you'll get a heads all 3 times? What's as certain as not really mean, you guys? Come on.
Will you have like the same?
As certain as not, it'll either,
It will or will not happen.
It's a 50-50 chance. It has a 50% chance of happening as much as it has a 50% chance of not happening. So as certain as not is
Not
50%.
likely.
So this is between 0 and 50%. So
This
it's
is highly
unlikely.
unlikely.
And Brian wants to add the word highly to it. Okay. Okay, a bag contains 5 red marbles, 8 green, 8 white, and 7 green. What is the probability of randomly selecting a white marble, replacing it? Will you underline those words? That's kind of important. You put it back, and then you randomly select another white marble. So is this independent or dependent?
Independent.
Independent. When it's independent, then we just take the probability of one times the other. So we want the probability of selecting a white and then another white. So we really only need to find the probability of selecting a white marble and then multiplying it times itself, don't we? Well, first of all, we got to decide how many marbles are there total.
20.
So there are 20 total marbles. It's important that we have that because that helps us set up our probability for drawing a white marble. So what is the probability of getting a white marble? 8 out of 20. Now, what I'm going to suggest you do is when that 8 out of 20 is a fraction that can be reduced. Let's simplify it first. What is 8 over 20? What is that simplify? 2/5. Because 4 goes into 8 and it goes into 20. So we might as well simplify it first. Well, and then we don't have to simplify it after, because sometimes after the numbers get so big, you're like, oh, I don't know for sure. This would have been 64 over 400.
And it would have been 16 over 400.
So this
Or
is
no,
4
64.
over 25, 5 times 5. So there's our fraction probability. Well, what is that as a decimal?
0.16.
0.16. What is that as a percent?
16%.
16%. We have all of our forms. I'm not sure which way they want it sometimes. You gotta know how to get them all. Okay. Anybody got questions so far? The next one's a little bit trickier, so before we move on to it, let's make sure we don't have anything, questions lingering about those guys. We should talk about. Okay. Number 4, 10 cards are numbered from 1 to 10 and placed in a box. 1 card is selected at random and replaced. That tells us it's what?
Independent.
Independent. Okay. Another card is selected at random. So now it wants to know what is the probability of selecting a multiple of 3 and then a multiple of 2. This one we gotta write a little bit, we gotta say a little bit more. Multiple of 3 and followed by a multiple of 2. We're finding the probability of selecting a multiple of 3 followed by a multiple of 2. 10 cards altogether. So we gotta figure out the probability of each of those because we're gonna multiply them, aren't we? Well, we gotta figure out the probability of a multiple of 3. How about let's take the time to do this. Let's write down what those cards would look like. Let's pretend we're making a set of cards here without actually. We have cards 1 through 10. Because this one didn't say drawing a 3, it said a multiple of 3. How many cards are there that are a multiple of 3? 3 of them. We really have 3, 6, and 9. They're all multiples of 3. So we have 3 out of what? 10. And then the other one is a multiple of 2. So now we got to figure out how many multiples of 2 are there. We have 1, 2, 3, 4, 5. All the even numbers are multiples, so we have 5 out of 10.
Can't you simplify that to 1/2?
Yeah, let's do that. Let's just take that right away and make it 3/10 times 1/2 instead. Then we don't have to simplify in the end. 3 times 1? 3. 10 times 2? 20. There's our fraction probability, which is 0.15 is its decimal name. And its percent name would be 15%. Okay. Yes, we are. Okay, independent events. Now we'll do dependent on the back side. So anything we need to talk about yet with independent. What's going to be the key word you're going to look for?
Replace.
Is replaced. Is replaced. Is it going to always say that though? No. Do you have to replace something when you're rolling a number cube? No, the numbers don't wipe off. Do you have to replace something when you toss a coin? No. So sometimes you don't have to say the word is replaced because there's no reason to. It's not really gonna go anywhere, it's gonna be there the second time, okay? So, when I say is replaced is a key word for independent event, it doesn't always have to be there. You gotta also know what would be other situations where it would be, not have to worry about it having to be replaced. Okay, let's underline this one now. Events are dependent if the occurrence of one event does affect the probability of the other. So very important that you gotta, if one is going to affect the other, then you gotta take that into consideration because it's gonna be a little trickier. The second probability depends on the first outcome. So if A and B are dependent events, then the probability of A and B, notice, we don't just take the probability of A times the probability of B. We have to say, oh, the probability of A times the probability of B after A has happened. In other words, something's gonna change because of A. Something has to change because of A happening, and so I have to take that into account. So if we have our example here, a class has 18 boys and 12 girls. 2 students are chosen at random. So if I choose 2 of you to get to leave at 12 o'clock today for lunch, and I say, you know, what's the probability that I will choose 1 boy and 1 girl in this classroom? If I happen to choose Trevor first, is that going to affect the probability of me choosing a girl?
No,
Why not?
because these aren't lesson guys.
Oh, but wait a minute, Trevor's already been chosen. Is he gonna come sit back down again? Or is he gonna split? He's gonna be like, I'm out of here, I'm the boy, I'm out of here.
Yeah, he's gonna leave.
Okay, there's 9 of you in here right now. So after he leaves, how many will be in here? 8. 8 of you will be left. That changes the total on the bottom, doesn't it? The girls' number doesn't change, does it? But the total number of students left in the classroom changes. So that's what's happening here. They want that to have a much bigger class size. So notice it says the probability of a boy, 18 out of 30 students in this class are 18 boys that we're talking about here. But notice what changed. After that boy got chosen and was out of here as fast as possible, there were only 29 students left. Of those 29 students, 12 of them were girls. So instead of it being 12 over 30, it's 12 over 29. So then it gets multiplied out. Okay, and then it says, here's an example of what's the probability of selecting 2 boys. Oh, okay, this is really important you catch this also. That boy got chosen. In this first one, 18 out of 30 were finding the probability a boy got chosen. That boy's gone. Did that affect not only the size of the class, but it also affected how many boys are left, right? So the boys went down to 17, and the total class went down to 29. So we had to multiply by 17 29s if we want to get the second time.
There, like the one where you circled, where'd they get the 12 from?
So many girls there were.
That's how many girls were in the class to start with. Right here. There were 12 girls. Okay? So 12 girls out of 29 total students. And down here, there's only 17 boys left now out of 29 students. Okay, so let's go take a look at number 5. We have this bag that has marbles. 3 red, 5 green, 2 blue. So first of all, how many marbles are there total?
10.
Okay, so let's just write that right here. 10 total marbles. Three plus 5 plus 2, 10. Okay? So a bag has these marbles. What's the probability of selecting a blue marble, setting it aside? So did it go back in the bag? No, it got set out. It got set aside, and then selecting a red marble. Is this independent or dependent? This is dependent. Setting aside is not replacing it, it's not using it again. So probability of getting a blue. What's the probability of getting a blue?
1/5.
2 out of 10, which does equal 1/5, right? Simplified. Okay, what's the probability of getting a red after that blue's been drawn out of the bag? There's only 9 marbles left in there now,
So 1/3.
And there's 3 of them that are red, so we said we have to do 10, take away 1, that's where we get the 9, because we already drew a marble up. 10 take away 1, 9 marbles total now, 3 of them are red, that simplifies to 1/3. So now we're gonna take 1/5 times 1/3, and what's that become?
1/5.
1/5 times 1/3?
Oh, 1/15.
1/15. Written as a decimal, how does that one look as a decimal?
0.06 repeat.
0.06 repeating, 0.06 repeating, which remember that now means that would be 6.6 repeating for a percent, but we're not gonna leave it like that.
6 and 6.
It would be 6 2/3%. So there's our percent answer, here's our fraction answer, here's our decimal answer. Anybody unclear about any part of that? Okay, then let's go to the next one. We have 26 cards with the letters of the alphabet, because there are 26 letters in the alphabet. They're put in a box. What's the probability of selecting a vowel? A, E, I, O, U, they're not counting Y. Setting it aside and then selecting another vowel. No, there's 26 cards total in this box. So we are looking for the probability of a vowel. And then we're going to have to multiply that times the probability of a vowel after 1 is gone. Let's just write it like that to help you make sense of it. So we don't need, So we got a vowel probability, because it wants to know what's the probability that we'll select a vowel, set it aside, in other words, not put it back in, and then we'll select another vowel out of there. So what's the probability we'll select a vowel the first time?
5/24.
5 what?
5/24.
Why 24?
I'm at 26.
Yeah, there's 26 letters altogether, right? So there's a 5 out of 26 probability of selecting a vowel that first time. So we drew out that vowel, we set it aside. What's the probability of getting a vowel the second time?
4.
4 out of 26.
No, is it for?
Oh, out of 25, because why?
Yeah,
We got rid of, that vowel, we didn't put it back in. There's one less vowel, there's one less card, isn't there? So it's 4 out of 25. And this one would be easier to, okay, before we go crazy with our calculators, let's do this. 5 goes into itself once, that's upstairs. 5 goes into 25, how many times?
5.
5, that's downstairs. Remember, we can do that, simplify before we multiply. Does 4 go into 26? But what does go into both of them? 2. They're both even numbers, so 4 can be divided by 2, you get 2. 26 divided by 2 is 13. Don't cross them out so you can't read your numbers that were there originally, but enough that you can. So now, 2's can't go into 13 or 5 downstairs, so I say I'm ready to multiply across. 1 times 2? 2. 13 times 5? 65. Pretty slim chance, right? 2/65. This one we're going to have to just round. This one isn't going to come out to something I don't think. Is this what does it divide out to?
0.030769.
Yeah. Let's take it to the thousandths place first of all for the decimal. So 0.03, what should be in the thousandths place? 1, okay. And then that as in a percent then is also,
3.08.
no, let's just.
3.1.
3.1% approximately, so. We rounded to thousands, so we can have a tenths place in our percent, okay? So there's our 3 different ways for the same probability. Okay. Got a bag with marbles again. How many marbles are there altogether? 20 total marbles. Let's write that down. Okay. What's the probability of randomly selecting an orange, setting it aside, in other words, not putting it back in, then randomly drawing another orange one? So we need orange followed by orange again after one orange is already gone. So what's our probability of selecting an orange the first time?
8/20.
8/20.
Which is 2/5.
Well, we won't simplify that quite yet, okay? And then we're gonna multiply that by the probability we'll draw an orange the next time and we didn't put anything back. How many orange are left now? 7 out of 19 total marbles left. So there's 7 out of 19. So now we can, let's simplify our 4, no, we don't want 4, we want it to be 2/5, right? 4 goes into both of them, so we have 2/5, 8/20 simplifies to 2/5 times 7/19. And what you want to do, especially in a problem like this, you want to make sure you can't do any more simplifying before you multiply, because if you can't, then you know that your answer can't be simplified either. So can 2 go into 5 or 19? How about 7?
No.
No. Okay, so now we're gonna say, okay, 2 times 7 is 14. 5 times 19 is 95. So there's our fraction probability. I'm gonna guess we're gonna have to do round to the nearest thousandth again. So 0. What? 147. There's its decimal approximation, and its percent approximation would be 14.7%. Okay. Questions on that one at all? Anything we should talk about? So okay, then let's go on to our last one here. We have 10 cards that are numbered from 1 to 10, placed in a box. What's the probability of selecting an even card, setting it aside, not putting it back, and then selecting an odd card? Well, maybe we should do this. 1, 2, 3, visuals. What do those look like? What do those look like? How does 1 through 10 again? Well, we want an even card the first time. How many even cards are there? 2, 4, 6, 8, and 10. So there are 5 even cards out of how many? 10 times. We'll simplify later. And then we want to select an odd card. We didn't put the card back. How many odd cards are there?
4 or 5.
We took an even out of there. How many odd cards are there? 5. There's still 5 odd cards though, because we have 1, 3, 5, 7, and 9. None of those were even, so they are still all there out of 9 cards though, because we didn't put that card back from the first draw. So now, let's do some simplifying. 5/10 is 1/2 times 5/9. Okay, how do you feel about that? Can anything happen with any more simplifying be done before we multiply?
No.
Anything go into 2 that goes into 5? Goes into 9 that goes into 5? No, so it's 5 what?
5/18.
5/18, there's our fraction probability. What happens when we divide this one out?
0.272.
0.02 or 2? 2, okay. And the 7 repeats until it's an 8 at the end, okay? And that means it is, notice I'm not using the approximately equal to sign now because we saw that we have this repeating pattern that we happen to know what it is. So we have 27 and 7/9%. This can be rewritten as, we can take this, we can say 27.7 repeating percent, which is 27 and 7/9. Okay, so when we have to keep track of when we have an independent event versus a dependent. Now, on the worksheet, it's not going to separate it like it did in our notes. The front's independent, the back is dependent. You're gonna have to make that decision as you are working this. Okay, make sure you read what it's asking. I think you actually can show your work. I think I have enough white space on here for you to show your work on the sheet.